Look closely at this ancient wrought iron. While a modern car would rust through in decades, this pillar has stood defiant since the Gupta Empire. This accidental byproduct of ancient engineering repairs itself at the molecular level, converting oxygen from a corrosive force into a permanent protector. This is a 6-ton, 7.2-meter-tall solid iron monolith. It has stood completely exposed to the open air for 1,600 years. Ordinary iron structures degrade rapidly. Oxygen and moisture systematically strip electrons from the metal, causing it to flake away into red dust. Delhi's climate should have accelerated this destruction. The region experiences relentless cycles of heavy monsoons and high humidity, the precise environmental ingredients required to trigger severe oxidation. Standard chemical models suggest this iron should have returned to the Earth centuries ago. It remained a forensic mystery for decades, until researchers published a definitive chemical map of its surface in 2003. The metal dates back to the 4th or 5th century, during the height of the Gupta Empire. Ancient Indian blacksmiths extracted iron from local ore using a solid-state reduction process. Unlike modern industrial producers, they did not use lime in their smelting process. This chart shows the structural makeup of the iron. Because they skipped the lime, the metal absorbed an unusually high concentration of phosphorus, around 1%, drawn from the specific charcoal in plants used as fuel. The manual forging technique also left behind microscopic pockets of unrefined waste called slag inclusions, which are scattered unevenly throughout the metal matrix. These inclusions made the iron highly reactive. When the pillar was first erected, those jagged slag pockets acted as catalysts for decay, and the surface began to corrode at a high rate. But the blacksmiths had inadvertently built a chemical defense. This initial burst of surface corrosion was the trigger required to activate a permanent protective layer. As the initial oxidation reaches the trapped phosphorus at the surface interface, the chemistry of the rust changes. On a molecular level, the phosphorus catalyzes the formation of mesowite, a dense amorphous layer of iron oxyhydroxide. Instead of the loose, flaky fixture of typical rust, these molecules lock together into an impenetrable grid. The local climate drives the reaction to completion. Delhi's cycles of soaking wet monsoons followed by extreme heat force the mesowite barrier to condense and pack itself into a crystalline wall. This final layer of iron-hydrogen phosphate hydrate has almost no porosity. It creates a physical seal, blocking new oxygen and moisture from reaching the raw iron underneath. If the surface is scratched, the system heals. Exposed phosphorus immediately reacts with ambient oxygen to regenerate the shield over the breach. The pillar systematically transforms atmospheric oxygen into a reactive, impenetrable protection. Modern industrial metallurgy takes a different approach. Today, massive blast furnaces melt iron into a liquid state to ensure a uniform product. Steelmakers now intentionally strip phosphorus out of the metal. If left inside, it causes hot shortness, making the steel brittle and prone to cracking during the rolling process. By purifying the iron for mass production, we remove its internal defense mechanism. Modern infrastructure is susceptible to decay unless we maintain it with constant artificial coatings. We cannot easily replicate the Delhi method today. It relies on manual hammer forging and uneven carbon levels, variables that modern blast furnaces are designed to eliminate. The pursuit of mass-produced uniform structural steel resulted in the loss of a method for material endurance. Material engineers are now studying the pillar as an active blueprint for next-generation alloys. The goal is to integrate these phosphorus catalyst techniques into modern steel production. Successfully doing so would allow for carbon-neutral infrastructure that requires zero maintenance. The solution to building truly permanent infrastructure has stood in the center of a Delhi courtyard for 16 long centuries. The past is full of secrets just waiting to be uncovered. To join us on our next deep dive, make sure to subscribe and turn on notifications. Don't forget to click on our other videos to keep the journey going. Until next time, stay curious.